This will be a short video. I'm going to compare ionic and covalent compounds. Now, this will be some of the same information you already got and a little bit of new information. So the first thing that I'm going to talk about is covalent compounds. We call covalent compounds molecules, and we call ionic compounds formula units. Now, a couple other things just refreshing our memory. Well, where is it? Hold on. There we go. Covalent compounds, the electrons are shared between the atoms. So in this HH bond, there is some sharing of electrons, and this dash represents the shared pair that is linking them together. And remember, in ionic compounds, there's no individual link between the atoms. There's just a lot of little weak forces that net attractive forces that keep the crystal structure packed together. Um, and the reason there's attractive forces is because there's opposite charges. And the reason there is opposite charges is because electrons have been transferred. When an electron transfers from one atom to another, that will make the atom that gains the electron negative. So in this case, chlorine is more electronegative. It is better at stealing electrons or attracts them better. So it gains an electron, becomes negative. Sodium is less electronegative, and it is positively charged. Now, the reason covalent compounds share is because both atoms in the bond have about the same electronegativity. There's not a lot of difference between it. So one atom isn't capable of stealing it or ripping the electron away from the other one. But in an ionic compound, that's not true. There's a huge difference. So one atom's really good at attracting electrons and one atom's really bad. So the more electronegative atom will steal the electrons. Now, covalent compounds tend to be gases, liquids, and if they're solids, they tend to be soft solids. They also, yeah, we'll just go with that. So gases and liquids mostly, or soft solids. And then ionic compounds are crystals, so they tend to be solids and more brittle solids. Okay, so some comparisons. You have this in your note outline. The individual bond strength, covalent versus ionic. Covalent wins that. Covalent has a much greater individual bond strength. Remember the attractive forces between each individual atom in ionic compounds is very, very weak. But a lot of weak attractive forces adds up to a strong crystal structure. Now the melting point, ionic compounds tend to have, excuse me, ionic compounds tend to have much higher melting points. They also tend to be harder and more brittle. I already talked about that. And because the electrons are transferring around, ionic compounds are also much better electrical conductors than covalent compounds. And the last one, lattice energy, we've talked about that one with ionic. Ionic has a much higher lattice energy, and I will elaborate that on that in the next slide. So for now, just get down which one is greater, which one is weaker. Know this for the tests. And here's why. So I like to try to explain why, not just tell you what's going on, but why it's happening. If you can understand the why, you don't have to memorize as much because you can reason through it on your own. Okay, so the bonds in ionic compounds are held together by a strong attraction between positive and negative charges. Now, this is a little bit misleading. So the strong attraction, I said, wait, there's weak interaction. So I want to clarify it. If I'm looking at this big crystal here, there's a strong force holding it together as a whole. That's what I mean by strong attractive force holding this together. But individually, that's very, very weak. There's a very, very weak force holding those individual atoms together. So and that compares to covalent compounds. If I look at these two atoms, they're held together by a very, very strong force. But the molecules themselves, this is very weak. This is why water, if you heat it up, it will boil at 100 degrees Celsius, whereas like a salt crystal, it melts much, much higher than 100 degrees Celsius because the overall force here is much greater. Now, the individual forces within a molecule of a covalent compound are very, very strong, much stronger than the individual ones here, but the total force holding the substance together compared to like the total force holding these together, ionic is much bigger. So ionic has a bigger, is stronger at holding the substance as a whole together. Covalent compounds tend to be weaker. But the individual forces between atoms is much stronger in covalent. And I know that's a little tricky to understand. Um, we can talk about that more in class, so I can explain it more if we need to. Just let me know. The reason ionic salts are brittle, and there's an extra T in there, darn typos. The reason ionic salts are brittle is once the crystal, wow, lots of typos, once the crystal is disturbed, the repulsive force is very strong. So if I were to take a hammer, let's say I have a hammer here, looks like Thor's hammer here, and I pound on this crystal, right now, there's a pretty good attractive force here, right? We got positive and negative lined up. But if I disrupt this crystal with the hammer and knock it out of place, now all of a sudden this is all repelling, and the crystal, this chunk, will fracture off, and you'll get a fracture right here. So that's why ionic compounds are very brittle, is because once you disturb that crystal, all of a sudden the attractive forces turn into repulsive forces, and that crystal will fracture at that point. And that's also why covalent compounds tend to be softer. If you think something like butter, there's no rigid structure between these molecules. There's no strong interaction here. So they can slide around each other a little bit easier, and I guess you can say squish out of the way, whereas this is a much more rigid structure over here. And that is actually all this video is going to be. So make sure you understand some of the properties between ionic and covalent compounds, and there we go.